Welcome to Milak Online tutorial. Now before us, we're looking at the verification of the refractive index of a glass prism. And here is the formula that n equals sine, then in open brackets, minimum deviation plus the refracting angle of the prism all over 2, close bracket, all over sine the refracting angle of the prism all over 2. Okay, now to bring this formula to its simplest form, it implies this is just according to Snell's law that the refractive index equals to what? Psi I all over what? Sine R. Okay, now yi is the angle of incident and R is the refractive what? Angle. Okay, now let us now start by bringing out those expressions for the incident angle and the refracting angle. Okay, so it implies that I here equals to all this expression, then I here equals to A all over 2. So how do we derive all these expressions from this diagram? Okay, now let's start with, now this is the normal. Okay, all right, because the normal is actually that part or that point which the incident ray enters into the prism and leaves the prism. Okay, all right, and that is why it's always at 90 degree. Okay, now to the prism. Now the incident ray lands at the normal, forming an angle. This is the incident angle. Now it's actually refracted. Okay, so the angle here, now this is actually the normal. Okay, so this angle here is called the refracted what? Angle. Okay, because there is a sort of refraction. Now it now travels this pattern. On getting here, that's as it tends to leave the prism, now it emerges out here, now forming another angle here. Now this is called the emergent what? Angle. All right, and this prism is an equilateral prism, which implies that this is 60 degree from equilateral triangle. Now this is 60 degree and this is what? 60 degree. Okay, now the angle, the incident angle here is always equals to the emergent angle, which means we can write this also as I. Okay, now let's make this one just I1, which is the angle of incident, and I2, which is the incident that emerged after refraction. Okay, all right. So in this case now, if we also presume that the incident ray is coming towards this part, towards the emergent ray here, it also follows the same pattern and come out here. All right, which also implies that as it comes here, this one also is formed. That is the refracting angle. All right, so let us make this one 1 and let us make this one what? 2. Okay, all right. Now here we go. Now for the incident ray, we presume that normally it should actually move this way. Okay, and for this emergent ray also, it meant to actually go this way. All right, now this angle here is the deviation, all right, between the incident and the refracting the refraction, and here the same thing. Okay, now let us make this one D1 and this one what? D2. Okay, all right, so at this point here, this angle here is what we call the minimum deviation. All right, that's the minimum deviation. All right, so and the minimum actual deviation is the smallest deviation produced by the prism. Now here we will now start deriving the expression for incident angle and the refractive angle. Alright, now let us take a look at this d1, d2. Now the minimum deviation dm is equals to d1 plus what, d2. Now according to geometric law, that the external angle equals to the two opposite interior angle, that is the sum of the two opposite interior angle. So dm, which is the minimum deviation, is equals to the sum of the two angles, interior angles here. Okay, in the same vein here, r1 and r2 will be equals to, here this is the refracting angle, which is what, c, 60 here. Okay, all right, so here we have that a will be equals to r1 plus what, r2. Now, and because this is an equilateral triangle, it implies that the refractive angle of, from this end, r1 and r2 will be the same. So we end up having here, since they are the same, you have what, 2r. Okay, so we can see here that a equals to 2r, and making r the solid of formula, we end up having that r equals what, a all over what, 2. So it implies that we've gotten the expression for what, for r. Okay, here is it. Now let us now go for I. All right, now for I, now let us consider something here. Let us consider this angle. Now if you look at it now, you see that it's this angle formed here is the same thing as the angle formed here. All right, now let us recall that if you have this like this angle is always equals to this what, angle. All right, so which implies here that I1 equals d1 plus what, r1. Okay, so in the same vein also here, I2 will also be equals to this same angle here, the sum of d2 plus what, r2. All right, now adding the two together, now let us take note that this angle here is equals to this angle. All right, so we can end up saying this is 2i now plus, now let us come back here, that d1 plus d2 equals what, dm, then plus, then r1 plus r2 equals a from this equation here. All right, so to this end, our a here, so here we have 2i equals what, dm plus what, sorry, r1 plus r2 equals what, 2r, which is a, yes. All right, so there we have it, a. Now dividing both sides by 2, so our I equals what, dm plus a all over 2. All right, now that we've gotten for that of r and gotten that of I, so we can now say that relative index equals what, sine I all over sine r, which will now give us sine into dm plus a all over 2 all over sine a all over 2. All right, as simple as that. All right, if you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in physics and maths. Thank you and God bless you.